Welcome to the course Algorithmic Design. Okay, so I will open again the example from last week, the metaballs with maybe this metaballs attractor field outlines. Actually, that's the example that I had last time. And if I got just go from the top, and actually let's go into perspective because we will go into 3D very quickly. So if you remember what this does, it creates, it's very small, and actually do some adjustments here. Yeah, okay, minor grid line spacing, perfect. 0, okay, major lines every 10, okay, great. Perfect, okay, I think this is now what I wanted to have. Okay, so this script, if you look from the top, you basically get these, you get this kind of bands, or so there are some, if I run this over and over, you get different, so in this bounding space, there is, there are these attractors that are placed, which have a certain charge, and then their influences are somehow compounded, and then the circles and the grid are created depending on how strong the influence is, or how strong the force is. So, so you have this kind of blending of influence here, and here with this thickness we can define. I forgot actually what number should be here. Let me actually save this. So I will show you now some variation of this code. So 210330, and I will call them metaball surface, something like that. Ephemeral. Okay, I hope these are right, ephemeral. Okay, so just see what happens if I change the thickness. Okay, yeah, so I get kind of a bit stronger, something a bit kind of stronger. Okay, maybe 0.7. Okay, let me check a little bit cell number, maybe a bit smaller, so everything is a bit faster. And then that's the number of attractor number, maybe something like 5. So we don't want to have too many. Okay, so this is like a surface, and now it's quite fast to run. This is important because I want to start layering this in height. Or so let's say I'm going to pretend this is like one floor, and now I want to go up. I want to kind of stack these ones up. So so basically, you're trying to now identify here in this code, you're trying to identify, okay, what is actually doing, what is here creating one layer, or this is creating, well, all this is creating one layer, or creating random attractor points. They're here. And maybe as I go up, these attractor points, if I go here and just say kind of, copy. So what I want to do is maybe something like this. So I want to go kind of up in height to start basically pretending these are my floors. And then as I go up, kind of the surface is being created. At the first, we will create it like just an extrusion, but then later we'll start to change the positions of these maybe charges, so the whole surface will start to kind of modulate a little bit. Okay, so creating random attractor points. So this we can maybe keep. Here says main loop drawing circles here. So this we need to put in a loop. Also, there's some kind of thickness, but there's also some, there is something called, let's call it NR, number of layers. Okay, so we're going to have some number of layers. And here we can maybe just do quickly just 10. And then here I can also say something like layer offset, some number, maybe here, again, maybe put 5. Okay, so this whole main loop that creates one layer, this needs to go into another loop. Or so I can say 4, and then I have to choose iterator, so the counter. Here I choose end. Maybe I can just say L. Gotta be careful that this is L, this is not 1. For L in range. And number of layers goes in here. So that's how many number of layers we go. And if I just indent this, so I select and press tab, all of this will now become kind of, I'll just go in. I apologize for making it very tiny, but so it fits on the screen. Okay, so all of this is now, this will now happen 10 times, but the height is still the same, or the height of these ones is the same. And we can kind of now, we can either move attractors up and then sort of move everything up, or we can pretend like, no, actually we are generating everything on the ground floor on this XY. We're doing everything there, and we get the result, and then we will just kind of shift everything up. So all of these circles, we can just kind of, or let me just actually think a little bit. Yeah, yeah, maybe here, just before we add a circle, we can just shift this point up, or because this point is being recreated here. Well, actually, just think. Okay, we have to be careful here with these distances. So we have a point, and then we calculate the distance. So maybe just before the circle is drawn, we want to shift the point, or so we want to say something like, something like shifted point is basically plus equals the old point plus some rg dot vector 3D. So again, because I use vector 3D and point 3D, which are these Rhino geometry objects, I can just add them together. So if I add a point and a vector, I'm basically translating the point. So that's just a notation convenience. So I can basically create, actually shifted point equals old point. So we're not adding, but we are kind of saying it's the old point plus some vector. And this vector has x and y 0, and the z component, so the height will be this layer offset. But it's actually layer offset multiplied by the number of the layer, or number of the layer is this L. I hope, again, this L will not confuse you, that you will not think that it's 1, but it's actually L. Okay. Okay, and then that's my shifted point. So instead of adding a circle at the point, I'm adding it at the shifted point, which is the point that is higher up. Okay, and this should already work. Just run it, let's see what happens. Now this layer should be created up. Okay. Yeah, perfect. And this is just 10. So maybe we make a bit of a bigger distance between. So layer offset is maybe 20. So just to have a bit of, okay, something like this. And these are now some kind of floors, and now the question is, what can I do? What else can I do? So either I can move where the charges are, or I can maybe even say, well, let me see a little bit. So where do we change the charge? Or the charge is here. Okay, the charge is changed here, and we divide it through sort of a distance. But actually, this charge, I can make this charge also dependent on the layer height. Okay, so if I put now this in the brackets, this charge, so this charge is like the influence of the point, and it's a random number here. Where is it random? Where do we create it? Yeah, it's here. It's actually the same for every point, but I can make it, I can multiply it, for example. I can multiply it by, the layer number. Okay, and maybe that's a bit too much. So layer number, I can maybe even go kind of 0.1 or something like that. So it's let's see what we get. So I kind of added some. I just realized this L, this one, to look exactly the same. So no, actually this is not one. This is, yeah, this is L. Okay, let me just rethink this. Let's call it Ly. Okay, so let's not use L because Ly, you're just gonna get confused. Okay, so now the charge is increasing as we go up, but it's increasing not that much. So increasing by by kind of 1/10 of this layer number, or so we are kind of just scaling as you go up. That means the surfaces will start to sort of slowly merge as we go up. Oh yeah, they kind of become, yeah, they'll just put more layers in here, number of layers, maybe 20. Now, unfortunately, they will become kind of, they will eventually merge into a surface. So they will just become, yeah, they are kind of becoming very, yeah, so they kind of very quickly, they start merging. But just thickness, what was that? 9. Okay. So basically as we go up, the charge is increasing. So these isosurfaces are kind of becoming bigger. Okay. And let's go even more. So maybe number layer offset, number of layers. Let's put 100, why not? Okay, so now I'm basically changing the number of layers with the offset. This thickness I changed, and as I go up, they will basically all merge, or so it'll just become one surface, or sort of all of these circles, or all these parts of the surface, they will all merge, because when the charge becomes very big, then the influence is so great that basically every point will sort of not be drawn. So it'll all kind of become the inside of the surface. Okay, something like that. So you can see that basically as we go up, it just becomes this border, it sort of starts to disappear. It doesn't exist anymore. Okay, if I go look from up, it still looks a little bit like the. Well, it doesn't really look, but it's sort of, still, everything is bound to this square, and you can see where the original charges are. That's where they start off, and then also all the circles, they all overlap somehow in a weird way. Okay. Yeah, they kind of, yeah, they overlap in a weird way, but basically you get this sort of some kind of a functional surface. Okay, and now of course it's not really a building, but it is some kind of a shape, and we could now there are different things that you can do. So you could, for example, start moving these charges around. And actually put here, just run this faster. Okay, so what you can start doing here is you can, for example, start moving the charges around. Then they will start sort of overlapping, even if the charge, the amount stays kind of very, very low. So you can start moving them around, but it's better to do this in a sort of continuous way rather than sort of erratic. But you can make these charges move around. We can even make the charges kind of behave a little bit similar like the particles that we did at the beginning of today's session. So a particle was basically just a point, it was just moving around. And here you can say, well, the origin of this charge is that particle, and that's where the particle is moving. Here the charges are at the same place, their just influence is becoming kind of bigger. Here what we changed is just the thickness, or the thickness of the surface became a bit bigger. Yeah, until it kind of goes up and eventually sort of merges. And yeah, there's not really time for that, but actually, let me see, attractors append. Yeah. Yeah, so I will not do this example, but for example, you can, if I just open it, the one that we did today, this attracting particle system, or so we have the, actually, let me just see how fast I can do it. So surface ephemeral, let's do another one in this very few minutes that we have. So let's just try to merge this particles and this one here, save as. I didn't test this before, so I don't know how fast it is. Metable surface ephemeral particles. Okay. Nice naming. Okay, so for example, I would just take this class here, and I would copy paste it here on the very top. Okay, so now the class particle is here. We can in theory also load it from this file here, but here we just kind of copy pasted it and just put this number of layers down to maybe just 10. And this one we can also just, what was that, 9. So I'm just run this quickly. See how fast this is. Okay, so I want to just move these particles around. So maybe maybe this layer height, but maybe this influence is even smaller. So maybe something like this. Actually 0.5. Okay, and I want to change actually where the attractors are. Or so how do we do that? Random append attractor. Just think about it. Okay, so instead of using these attractors, random to the point. We have it here. Okay. Actually, this is not so fast. Yeah, I just realized that. So I will try to do this, and then maybe can look at it next time, because we have a function that returns us a point, and then we want to use that point as basically our particle, and then we have to, inside this loop, we have to actually move this particle around, or so basically the same thing that we are doing here, moving the particle around some kind of a attractor. If I can just run this, you can see it. Okay, so this particle is now sort of moving around in these orbits, and I basically would want to, for every layer, I might want to associate every position here to one of these charges. Or so in that way, I have to basically merge what I have here to what I have here. So I have to be a little bit kind of smart how I sort of do it. Here in these metaball surfaces, we have just kind of random points, but basically I want to start with the random point, but then I want to again start kind of moving them around. So I have to be very careful how I'm what I'm plugging in where. But it is possible, or I can kind of merge these two, and maybe I can do it for the next time, and we can start off that.